All right, so this section is going to be working on solving logarithmic equations. Now remember that exponential equations and logarithmic equations are inverses of each other. So the method we used to solve an exponential equation was to convert it to a logarithmic equation, because that was the inverse, which is how you undo or solve for it. And so therefore, if we are given a logarithmic equation, we will solve it by converting it to an exponential equation. And so that's the method we're going to use on some of these. All right, so the first one, this is just your basic logarithmic equation. We're going to convert it to an exponential equation, which would be the base value 3 raised to the 5th power is equal to the x plus 2. And then solving for x, you're going to subtract 2, which will give us 3 raised to the 5th power minus 2. And 3 to the 5th power, if you choose to multiply all that out, that is 243 minus 2 would give us 241 for a final value here. All right, so now the next one will also convert. So this becomes 2 raised to the 4th power is equal to x squared minus 6x. Now this one is a quadratic equation, so we need to set this equal to 0. And so that is going to give us x squared minus 6x. Now 2 to the 4th power is 16, and we're going to subtract that over to the other side. So you're going to have minus 16. Now if you factor this, factors down to x minus 8 times x plus 2, giving us values of 8 and negative 2. Now you need to remember that you need to check your solutions. If we substitute 8 in here, that gives us 8 squared is 64. 6 times 8 is 48. And 64 minus 48 is 16. Log base 2 of 16 is 4, because 2 raised to the 4th power gives us 16. Let's try negative 2. Negative 2 raised to the 2nd power is 4. Negative 6 times negative 2 is positive 12. And 4 plus 12, that's going to give us 16, which is a valid solution as well. So we do have two values of x that will satisfy this equation. All right, so the next one, this time we have two logarithms, and what we want to do here is combine or condense these logarithms. And remember, when you have logs that are separated with addition, you condense them by multiplying the 4 and the x together. So this becomes the log of 4x is equal to 2. Now it's down to a logarithmic equation, and this log has a base value of 10, so we can convert to an exponential. This would be 10 raised to the 2nd power equals 4x. 10 squared is 100, and dividing by 4 will give us x is equal to 25. All right, so the next one, again, we have two logarithms. This time we were going to condense them, but because there's subtraction in between, we condense through division. So this becomes log base 9 of 2x plus 1 over 2 equals 3/2. All right, so now we're going to convert this to an exponential equation, which would be 9 raised to the 3/2 power equals 2x plus 1 over 2. Now 9 raised to the 3/2 power. Remember your numerator, when you have a fraction for an exponent, the numerator is the power, the denominator is the root. It is easier to take the root first. So this would mean the square root of 9, which is 3, and then raise that number to the 3rd power. So 3 raised to the 3rd power is 27. So that is equal to your 2x plus 1 over 2. All right, we're now going to move this 2 over to the other side by multiplying it. So that gives us 54 equals 2x plus 1. We're going to subtract. And then dividing is going to give us x is equal to 53 over 2. All right. This time it's a little bit different because we have logarithms on both sides of our equation. So like before, what we want to do is condense these two logs. Now remember, the first step to condensing is if we have a number in front of the log, we need to move it to the exponent. So that's what we're going to take care of first. So this gives us log base 4 of 3x plus log base 4 of 3 raised to the 2nd power, which is 9, equals log base 4 of 11x plus 8. All right, now we're going to condense these together, and because there is addition here, we condense by multiplying 3x times 9. That will give us log base 4 of 27x is equal to log base 4 of 11x plus 8. Now here's the difference between this problem and the problems we were doing before. In the other problems, we had a logarithm on the left side and we just had a number on the right side, and we just converted it to an exponential equation. Here it's a little bit different because we have a log over here, not just a number. So if this is an equation, that means, again, the left side is equal to the right side. And if you have log base 4 here, log base 4 here, in order for these two equations to be equal, this part has to be equal to this part. All right, so let's just write that part being equal. So 27x would have to equal 11x plus 8. And then solving for x, you're going to subtract 11x. And then dividing by 16 gives 8 over 16, which reduces to 1/2. All right, we're going to do a similar thing with this. We need to condense all 3 of these, but before we condense, we need to bring the coefficients to the exponents. All right, so this becomes natural log of 49 raised to the 1/2 power minus natural log of 2 raised to the 2nd power plus natural log of 27 raised to the 1/3 power. And we can go ahead and condense these because there's no coefficient. There is subtraction in between, so this would be natural log of 7x over 4. Now we can simplify each of these a little bit here, so let's go ahead and take care of that. 49 to the 1/2 power, that means square root of 49, that is 7. 2 squared, that's 4. 27 to the 1/3 power means cube root of 27, and that is 3. All right, now this is going to be the same thing right here as saying natural log of 7 plus natural log of 3 minus natural log of 4. So if we're adding natural log of 7 and natural log of 3, that would give us condensed natural log of 21, because you're going to multiply the 7 and the 3. Now this log right here is subtracted, so 4 goes into your denominator. And this equals natural log of 7x plus 4. And once again, you have natural log on the left, natural log on the right. That simply means that this part has to equal this part. So if we take 21 over 4, set it equal to 7x over 4. Now we could cross multiply this and get 28x equals 84. But another way of doing this is, since our denominators are equal, that means our numerators would have to be equal. Now this is kind of a special case scenario, but that works, and it makes it a little bit easier, because that just gives us 21 would have to equal 7x, which means x is going to equal 3. All right, so this next problem is a little bit different because what we are doing is not adding two logarithms. We have a constant right here. This is not a log. And so what we want to do with this is we want to take this constant over to the other side of our equation and bring this log over to the left side of our equation. That way we can condense these logs together. All right, so now another way we can do that, and probably the way that I would do it, is just to take this log over to this side of the equation so that we can condense the logs together. The whole idea is we need to get the logs on the same side of the equation here and the constant on the other side. All right, so that's going to give us 2 is equal to log base 3 of 6x minus log base 3 of 4. We can condense these logs, which would be log base 3 of 6x over 4 and we could reduce 6x over 4 is the same thing as 3x over 2. And let's convert this now to an exponential equation, because we have a log equals a number. Not a log equals a log, but a log equals a number. Therefore, we're going to convert this to exponential, which would be 3 raised to the second power equals 3x over 2. So we're going to 3 raised to the second power equals 3x over 2. 3 squared is 9. We're going to multiply 2 over to the other side, giving us 18. And then dividing by 3 gives us x is equal to 6. All right, so the next problem, it's a little bit different in this situation, but it's the same idea. We have logs, or log is equal to 3. So let's think about this conversion. If you go back to here, you took the base value, raised it to this number, and set it equal to what comes after the log. So we're going to do the same thing here. We're going to take this 4, raise it to the third power, and set it equal to this. All right, so that gives us 4 to the third power equals log base 4 of x. Now 4 to the third power is 64. And we can then convert this to an exponential equation, which would be 4 raised to the 64th power is equal to x. And we're by no means going to figure out what 4 to the 64th power is, because that is a very large number. Okay. All right. Take a couple minutes, and I want you to write these problems down and see if you can work these on your own. So go ahead and pause the video at this point, write them down, work them out, and then when you unpause, you can see the work on these particular problems. All right, so the first problem here is a little bit different because it was written as a natural log, but you just simply have to remember that natural log is the same thing as log base e. So we are converting this to an exponential equation, which becomes e raised to the 6th power equals this. All right, so that's right here. Your next step for solving for x, or isolating this, is to get rid of the power. So we take the square root of both sides, and the square root of e to the 6th is e to the 3rd, because e to the 3rd times e to the 3rd gives us e to the 6th. And then your last step is subtracting 2. So this would be our exact answer on this for x. All right, this one we're just condensing these two through multiplication, and we have a log on both sides of our equation. So that means this part has to equal this part, and then dividing gives us x equals 32 over 3. Right, here we are just condensing these. Because there is subtraction, we condense by dividing these two parentheses. Now, because we have a log equals a number, we convert it to an exponential, which is 2 raised to the 3rd power equals this parenthesis. And then just cubing this gives us 8, and distributing end up with x is equal to 3. All right, so what I want you to do then is go ahead and take a second, pause the video, and I want you to write down the problems here and try working them out on your own, and then unpause, and you can go through the results that are on here. All right, so here are your solutions to those problems. On the first one, remember we need to divide the 4 over to the other side first, convert it to exponential using e as your base value, and then solving for x. The next one, we had to move the 2 up to the exponent, which made it x squared. We condensed through division, and then convert to exponential. 4 to the 1st power equals this parenthesis. And then multiplying your denominator over gives you a quadratic, and set equal to 0 factor. Solving for x, you get x equals 2. All right, so the last problem then, we want the logs on the same side of the equation, so we're going to add this logarithm over to the left side, giving us this. We can condense these two logs through multiplication, so you get log base 2 of this is equal to 3. That's logarithmic equation. We're going to convert it to exponential, so that's 2 to the 3rd power equals this. setting the equation equal to 0, factoring, you get x is equal to 4 and negative 2. Now you got to remember to check your solutions, because when you substitute 4 back into your problem, that's going to give you log base 2 of negative 4. You cannot take the log of negative values, therefore 4 is not a viable solution. Okay. Negative 2, however, when you substitute it in, you get negative 2, which is a positive, so that one works. And the same thing over here, 2 minus a negative 2 is positive 4, so we can do that. So therefore negative 2 is our only solution here.